So who's pumped about linting? I actually don't believe you. But I appreciate the support. My experience is that most people don't care about linting. They think it's annoying. They generally try to avoid it, or like, you know, if you have a get commit hook, they'll like -- no verify to avoid the linting step. So I hopefully will convince you today that both that linting is cool and important, basically. And how to do it better than maybe you're doing it, I don't know. So yeah, with that, just real quick, anybody out there using ESLINT? Okay, everyone. That's great. You're all winners. Thanks. So in case you didn't already know why you should care about linting, you probably do a lot of code reviews, and you get some pull requests like this. And so many times it's like at the very last minute, like people are coming in, they're saying like, hey, I've got this small change, and if you could just review that by like Thursday, you know, I really need this to go to production this week, so if you could just hurry up, that would be great. And so, you know, code reviews are amazing, and I love them, and I hope you all do them and embrace them and just sort of like take the time to give really meaningful feedback. But ultimately, oftentimes these are last minute, and sometimes it's just too late to catch like real bugs and real problems in the programs. And so you're often either skimming it over and just saying like, well, this is confusing, or this is, you know, you'll maybe catch little things here and there that you don't like, little nits. Hey, could you rename this variable something else, more easy to understand? But ultimately, we don't have time at code review stage to give the best feedback in a lot of cases. And so, you know, I'm always trying to figure out, like, how can we give feedback earlier in the process? You know, what can we do to improve our code before that code review step? Because even though it's a great step, there's more we can do. And of course, like, some people like pair programming. For me, like, I don't know. I just feel uncomfortable. Like, either someone's standing behind me, like telling me what to do, or I'm standing by. Like, it's not a good situation all the time for me. Some people love it. Those people are great. They should use this technique. But for me, I just, I don't know. I think it's intimidating or something. So what I will say is, if you want to have more effect on the code, if you want to improve your projects and make sure that your friends that you're working on your programs with are doing a better job, you should really consider getting serious about linting. Linting will give you some power to let you improve code that you haven't actually seen yet. It'll improve code that, like, it's like you can sit in someone's computer, like in their IDE, and like whisper in their ear like good programming practices, like while they're still working on it. Like sometimes before they even save the file, it'll already have like a little red line telling them they did it wrong. And so you don't have to wait till the code review where they're like, oh, we have to get this in, like press the green button, please, we got to merge this. You can do it in their editor so they have time to actually fix the mistake. So it gives you power. It's cool. Linting is great and wonderful. But many, many times, linting sort of stops at the style guide. So we pick something like standard. We pick something like Airbnb. They're fine style guides. And we say, well, OK, we've got our linting for our project. It's all done. We're linted up. We know our code is going to be good. We don't have to fight over code style or any of that stuff. But actually, like, this is only a part way of linting. If you want to be super powerful with your linting and really help the teams and projects that you're working on, what I think you need to do is figure out how to recognize and enforce patterns with your linting. So really taking it beyond just the style, just the sort of, I don't know, complaining about spaces and indentation, which is nice to have consistency, but actually recognizing and enforcing patterns. And so what I'm going to do to show you that this is important is show you like lots of mistakes that people make with common JavaScript patterns. And when I'm talking about patterns, of course, it's like patterns like error handling, how you do modules, I/O, event handling, all those design patterns and ways that we do things in JavaScript. Those are things that we make mistakes on all the time, and those are powerful places where linting can make us do a better job earlier. So let's talk about error handling. Here we've got 3 kinds of error handling. We've got callbacks, we're throwing errors, and we're rejecting a promise. More or less, this looks good. Anyone want to just shout out what's wrong with this? They're strings. Yeah, these are not errors. So if you don't throw a string or don't call back, or sorry, if you throw a string or call back with the string as an error, you aren't going to get a stack trace. And in many languages like Java, like at PayPal, we have tons of Java programmers that we're teaching Node, and they might think it's okay to throw a string or call back with a string. But the problem is you lose your stack trace. What you should have written is something like this, where you actually create that new error object each time. This is a really, really easy thing to mess up, and it can create tons of bugs because, say, in your, let's say your uncaught exception handler or whatever in your Node.js program, you probably depend on that stack trace to be there so you can figure out where your program went wrong. But if you're only throwing a string, you're not going to get a stack trace. It's just going to say undefined, and you're never going to know what's wrong, and you're going to be sad forever and miserable. So don't do that. Instead, ESLINT, of course, has all sorts of rules, like no throw literal is a rule that lets you prevent doing this. But this is just one example. Let's talk about the callback pattern. I think the callback pattern is like the hardest thing about JavaScript. It's really so easy to mess up. So look at this carefully. There are at least two serious problems here. The first thing is that we are supposed to do the error first, but it's like, I'm trying to get the thumbnail here. I get the user, I get their thumbnail, and then I just want to call back with the thumbnail. It seems obvious that it should be first, but no, actually, it should be second. So that's trick number one. The second thing is that we forgot to handle the errors. The thing about callbacks is you always have to manually pipe up those errors all the time. If you forget to pipe up the errors, if something goes wrong, it'll just blow up, basically, and you will basically, once again, have no idea where it went wrong, and you'll lose a lot of context about the problem. And so with callback pattern, of course, we always need to return after calling back each time with the error, handle the error first, call back with null, and then the data that we're calling back with. It's a common pattern, but so many times, even if you look in your own code, if you go home and you look in your code, maybe you'll find one or two places where you mess this up. I mean, I do it all the time, honestly. So we use linters to search for patterns like this and to make sure that we're doing them correctly. Here's another example, promises. So I've been dissing callbacks, but promises, honestly, people come from callbacks like, oh, yeah, we're going to use promises. They're going to be so much better. But everyone screws them up so much. It's amazing how easy it is to screw up promises. They're deceptively simple. I don't know. They could be simple, but they're still confusing. So here's an example of messing up promises. Here you have this make a cake function. You're going to get the ingredients, and then you're going to mix them, put them in the oven, and take them out. I like eating food, so this appealed to me. And you see how it's all nested like that? Just like you were using callbacks, you have that wonderful nesting, and then instead of returning those promises, which would allow us to the error to bubble up, if there's an error, for example, in the takeout, you just leave it in the oven or something, it will, you'll never know about the error because we don't return that promise, and so it doesn't bubble. So the correct way might be to write something like this, where we have this nice sort of vertical line, and we use those arrow functions to return each of those promises. So there, the promises will automatically bubble up. Honestly, I said you might have callbacks that are done wrong. If you look at your promise code, I'm positive you screwed it up somewhere. Because every time I look at promise code, people are screwing this up. I was always hating on promises for so long because every example I saw looked way more nested and way more confusing than any callback example I ever saw. So I was sure that they were terrible until I sort of figured out that most people just find them confusing, like I always did. So if you do them properly, you get this sort of nice vertical line. They're somewhat easy to read, and they start to make sense. But again, it's not that they're a bad pattern. It's that many times we just do the pattern improperly. And linting can fix those problems. Here's another example, the last example of bad code I'll share today, which is mismatched patterns. So let's combine callbacks and promises. That sounds like a good idea, right? So let's say someone's refactoring the code. The person who wrote the code was loving promises. They wrote everything with promises. And then someone said, you know what, I'm more of a callback person myself. We're just going to rewrite that ingredients thing. And we're going to use, callback pattern at the top. We've got promises at the bottom. What could go wrong? Yeah, well, what is wrong with this code? So looking at it carefully, at the top, we're being very careful. We return with the callback and the error. And then at the bottom, we call back once we're done. So we should be good, right? Not so right. So we forgot the error handler. Because we're using callback pattern to wrap our promises, we have to pipe through that error again like we do in the callback pattern. So maybe we catch the error at the end of the promise chain, pipe it back up. Really the only point of this is to say, like, when you start mixing your patterns, it just becomes really hard to remember the best practices for that specific pattern. You're using callbacks, you remember to have that return callback error all over the place. And you sort of see it, and it's like, you know, like it's something good to see. It's like these poles over here. Like, you see those poles, you know that the building's not going to fall in. If one of those poles was missing, you could easily recognize that and say, maybe I won't sit over there or whatever. Like, it's a little bit dangerous. And so using patterns consistently, I think, is very powerful. You know, if you want to do this differently, maybe you'd use something like async and would just keep it all in callback land, or you can use promises and keep it all in promise land. They're both fine lands, but they're not such good lands when you start mixing them together. They just become confusing, and it's hard, and it's so easy to make mistakes, and it's just awful. So don't do that. There are a bunch of places where these mismatches can happen in your code, and I see this in my code all the time, in code I look at PayPal. One of the ones that's so confusing is this one where we have low dash and underscore in the same code base at the same time. Y'all seen that before? You know what I'm talking about? Like, ever inspect like your Webpack build and be like, why do we have 4 versions of underscore in here? Like, what's going on? This happens all the time. So we've got low dash and underscore, and you know they have like slightly different method signatures and slightly different edge cases, and we're always getting bugs to the point where I just eventually turn on this ESLINT rule that completely banned one of them from our code, so we could never use it again to avoid all of those bugs, because there were really bugs coming into our code base. And of course, like whether it's classes, modules, how you're using middleware, all of these are places where we can enforce a consistent pattern in our code base and find like way less bugs and just less confusion when you're trying to like think about how this is supposed to look. If you're used to seeing a certain pattern, if another pattern gets stuck in there, it can be really jarring and hard to think about it and figure out what might be wrong with that. It makes code review much more difficult if you're having to think about 4 or 5 different patterns at the same time. So I hope I've thoroughly convinced you that I write bad code. I think I've done it, and I know that you probably do it too, secretly. Maybe just in your open source projects, hopefully not at work. And you know, with that, I now want to empower you with tools that you can use to recognize and fix these things. So how many of you have created custom ESLint rules before? Yes. OK, those 5 people, if you have questions, you can talk to them. I'll be unavailable after the talk. So I'll show you the easiest way to get started writing custom ESLint rules. What you want to do is you want to go to this website, astexplorer.net. Now, you're probably thinking, like, what does that have to do with ESLint? But it's a really nice website. You'll see on the left-hand side you have some source code. This represents your source code. On the right-hand side you have an abstract syntax tree, which is, how many of you have dealt with abstract syntax trees before? OK, so like some of you. This is an important part of how ESLint is able to understand your code and like how you can write custom rules. So I want to show you a couple simple examples about what abstract syntax trees are in JavaScript. So take a simple function like this, function New York. If you were to describe this function, you might describe it in something like this. This is what the AST looks like for this function. So it says it's a type of function declaration. It has the name of New York, and it has no parameters. So that's the AST for this function. It's a JavaScript object that describes some code. That's what an AST is, essentially. Let's say we make a slightly more complicated version. We add the date parameter, and then you'll see we have now this params object, which contains a parameter with the name of date. So that's what an AST is, an abstract syntax tree, very basic version. That's what ESLint uses to try and figure out what's happening in your code so it can tell you if you're potentially doing it wrong. So go back to AST Explorer. Let's create our ESLint rule. Click Transforms, click ESLint, version 2. The website doesn't have version 3, but like it's basically the same, doesn't matter. So now you have 4 panes, source code, AST. then the ESLINT rule, your custom rule that you're writing, can go there. And then any errors that you see go down at the bottom. So I showed you at the end my biggest pet peeve, which is mixing promises and callbacks. So let's write a rule that will prevent anyone who's working on this code to mix promises and callbacks. It seems like a good idea. Who thinks this is a good idea? Y'all think it's a good idea. That's cool. All right. So here's our code. Again, we've got callbacks at the top, promises at the bottom. So we need to think about this. We want to prevent this from happening. So how will we do it? Well, first we need to detect if you have a promise. And then we need to decide if that promise is inside of a callback. Okay, so just 2 steps. There's really 2 things that we need to check for in order to make this rule. Now, once we have this rule, it will be wonderful because we'll never make this mistake again. So let's go back to our AST Explorer. And then I just kind of want to review what the AST of a promise looks like. So let's look at this super simple promise example. I have anything that I call then on. That's basically what a promise looks like. Like if I see something like this, I know, okay, they're probably messing with promises. So let's look at the syntax tree for that, because that's what ESLint's going to need to detect promises anywhere in our code. So here I've got, here's my AST. It's a little bit bigger than what we looked at before, but I'll walk you through it. So first thing it says is I have a call expression. Call expression just means I'm invoking a function. I'm calling something. Okay, I'm calling a function. And then that thing that I'm calling is a method on an object, or something called a member expression. The object that I'm calling it on is called do something, and the property is called then. That's basically the pattern. This is the AST form of the promise pattern. Anytime I see an AST form, a call expression with a member expression, with a property of then, I can say, okay, this roughly looks like a promise. And so I can use that. Once I recognize that pattern, I can use that to identify promises anywhere in ESLint. So here, let's go back to our code. This is now our rule code, our custom rule. We say, okay, if we have a member expression with a property name of then and a parent type of call expression, then we have a promise. Now I know what you're all thinking, like, I don't know ASTs, this is all complicated, I hate you, stop. And that's okay. Like, I just want you to know that it's doable. You can't learn in 15 or 20 minutes exactly how to write every rule that you want. I just can't teach that to you, but I can show you that it's very possible, and with a little bit of time, you can write the code to recognize and enforce pattern best practices in your code bases and make your code significantly better. So we've detected a promise, and now this is how in ESLint you report an error. You say context.report, you throw in the node or property that you want to report on, and it will show an error. So once we apply that to our code, you'll see in the bottom right-hand corner, we get a bunch of errors. So with just like 10 lines of code, we basically detected that there's a promise, and we reported on it. Now, the problem with this code is that we didn't detect that we're also in a callback. So it'll just ban any promises in the code, which is not exactly what you wanted to happen. So let me show you how you would figure out what the callback pattern looks like. We looked at the example of what a promise looks like in AST form. Let's do that for callbacks. The way that we'll do that using this tool is we'll click on the callback. And then you'll see on the right-hand side of the screen, you get this sort of ugly yellow highlighted thing that is the AST for the callback function. So let's zoom into that. And you'll see a couple important traits of what callbacks look like. What does that pattern look like in AST form? Well, you have a function expression. Okay, and if you're thinking in JavaScript syntax terms, like, well, it's not a function declaration. It is an expression. It's not like at the root of the file or anything, and it has a parameter, and that first parameter has the name of error. And like when you see a callback, it usually has that function error or error, depending on your whatever coding standards you follow. Just you can use either one in the code. So we're kind of saying, okay, if we have a function expression and the first parameter is an error as one of our parents, then we probably have maybe hopefully have a callback function. So this is what we're going to use to determine. We're going to write this function now, and it's going to be awesome. So we'll say, okay, let is callback equal context.getAncestors. That's basically saying anything that's a parent of that promise. Whatever happened before this promise happened. Now, if you're familiar with like jQuery.closest or .parents or whatever, it sort of looks up the tree, it returns an array, and then we use the sum method on the array prototype to say if any of these match the following, then we know that we're in a callback. Is it a function expression? Does it have at least one parameter? And does that parameter have the name of error? If all those things are true, if we have a parent that is a function expression with an error parameter, then we're probably in a callback. So we put that code in there, and then we can remove the callbacks, and you'll see that the errors go away. So the whole rule, it's like 20 lines of code or something like that. We detect a callback, then we detect a promise, and then we can report our error. That's really all that there is to it. And once you have this code, you can distribute it you can create a plugin and share it with the whole world if you want to, and make many friends and get many GitHub stars and get many Twitter followers. And people will be so happy that you built this rule because you solved the problem that they're going to have in their code bases as well. I maintain this rule, ESLINT plugin promise, and like thousands of people use it because we all screw up promises all the time. And it's nice to have someone else, yell at you about it while you're coding it rather than in the code review stage or just in the production bug stage, which is the worst place to find these types of bugs. So I hope that you've learned something today. One, I write some buggy code, but more importantly, you should really start thinking about your code in patterns. Like, think about patterns. Think about how you use patterns to make sure that you're applying those best practices. Learn the abstract syntax trees to make sure that you can really think about what's really happening in your code, and then potentially help you as you start writing ESLint rules. Obviously, do the best you can to use the lint rules that can apply to enforce best practices in your patterns. There are tons out there. There are tons of plugins you can use. You probably already use some of them, but consider using more. I think they really help a lot. And then create and share those rules to sort of scale your impact, your influence for good, and your ability to gain fortune and, well, at least fame on the internet. Like, people will think you're cool if you have a popular rule. That's like the best I can promise. But in closing, linting is cool and important. Do you have any questions?